Okay, greetings one and all, and welcome to this math video. In this math video, we'll be considering the topic mensuration, and this is mensuration part 2. Let's begin. Okay, the question says that the diagram represents an open water trough of a length 80 centimeters. The cross section is an isosceles trapezium of parallel sides 54 centimeters and 24 centimeters with slant sides of a length 25 centimeters and height 20 centimeters. And so the question asks us to calculate the total surface area of the trough. Now, in order to figure out the total surface area of the trough, what we need to do is we need to find the surface areas of each of the two-dimensional shapes that make up this three-dimensional shape, and then we're going to add all of those surface areas together. And so let's begin. So we're going to start off with this shape. This is going to be the front trapezium. So let me do that properly. We're going to start off with this shape. Let's go ahead and highlight it. Let's use the highlighter. And so we're going to start off with this shape. So this shape right here, one right there, this is definitely the trapezium. So we're going to start off with the front trapezium. And so notice that the formula for the trapezium, right? The formula for a trapezium is 1 over 2, right? That's 1 over 2, open bracket, A plus B, right? A plus B multiplied by H, right? That's the formula for the area of a trapezium. So if we want the area of the front trapezium, that's going to be this one, right? A is going to be 54 centimeters, just like how this is 54 centimeters, right? B is going to be 24 centimeters. So A is 54 centimeters, B is 24 centimeters. And then the height, right? The height, this part right here is 20 meters. Sorry, 20 centimeters, and that's going to be the height. So it's going to be half A, which is 54, B, which is 24, times H, which is the height. That's going to give us 780 centimeters squared, and that's the area of the front trapezium. Okay, now we need to figure out the area of the trapezium that's in the back. So the area of the back trapezium, all right? So the back trapezium is going to be this one, this trapezium right now, right? That trapezium that's in the back there. All right, so A is going to be 54, right? Because this top part is 54. This bottom part is also going to be 24, so that's 24 there. And then the height is the same, so it's 20. That's also 20 centimeters, and we multiply them, and we get 780 centimeters squared. So we did the front trapezium, we did the back trapezium. Now we need to do the bottom rectangle. So the bottom rectangle is going to be this rectangle at the base, right? The bottom rectangle, all right? And it's length times width. So the length of this, right? So let's do the length of this. Let's use a highlighter. The length of this bottom rectangle is going to be this length, right? That's the length. And that's the same length as this, which is 80 centimeters, right? And then the width is going to be 24, right? So this is the width, right? The width is going to be 24. So it has a length of 80 centimeters and a width of 24. So what that means is we have length which is 80, length which is 80 centimeters, width which is 24 centimeters. And so that means that the area of the bottom rectangle is 1,920. Okay. All right, good. So now let's move on to the next one. We need to find the area of the right triangle. Sorry, we need to find the area of the right rectangle. Okay, the rectangle on the right, that's referring to this particular rectangle. So let me highlight that one for you. You want the area of the right rectangle. So this one, it has lengths of 80 centimeters, and it has a width right here, and then the length right here as well, and then the width. All right, so that's going to be the rectangle that's on the, oh, I'm sorry, that's the left one. That's the left one. I want the one that's on the right. The one that's on the right is going to be this one. All right, so this one. So this is the one that's on the left. My apologies. That this is the one that's on the right. Okay, so this one is on the right. I did the one that's on the left. Okay, so what is going to be the length? Well, the length is going to be 80, right? It's going to be 80 because this one is 80, right? That's going to be the length, all right? And then the width is going to be 25, right? So 80, that's the length, right? And then the width is going to be 25 centimeters, right? That's the one on the right. Okay, Now, the answer, when we do 80 centimeters multiplied by 25 centimeters, that's going to be 2,000 centimeters squared. Now, let's do the area of the rectangle that's on the left. All right, so let's do that one. So that's going to be this one. So we have this one. The length is definitely 80 centimeters. All right. And the width is also 25 centimeters. All right. So the length is 80 and the width is 25 centimeters. So it's going to be 80 centimeters multiplied by 25 centimeters, which is also 2,000 centimeters squared. Okay, now let's add them all up because we did the area of the front trapezium, the area of the back trapezium, the area of the bottom rectangle, the area of the right rectangle, the area of the left rectangle. Now we need to add them all up. 780 centimeters squared plus 780 centimeters squared plus 1,920 plus 2,000 plus 2,000. That's going to give us 7,480 centimeters squared. And that's the total surface area of the trough. Okay, let's move on to the next question. Here, the question says that the Earth's orbit about the sun in a year is approximately a circle with a radius r of 1.5 times 10 to the 8 kilometers. And so they give us the radius, right? The radius is 1.5 times 10 to the 8 kilometers, and that's expressed in scientific notation. Using pi as 3.14, calculate, given your answers in scientific notation or standard form, the distance the Earth travels in 1 year. Now, when they say the distance the Earth traveled in 1 year, they're talking about, let's show it. They're talking about this distance, right? The distance of this circle, right? Now, if we are trying to find the distance of a circle, we're definitely going to be trying to figure out the circumference of the circle. Now, the circumference of the circle, the formula for circumference is definitely 2 pi r. That's the formula for the circumference. So what they're basically asking us to do is to find the circumference of this circle, where the radius, like we saw the radius, is 1.5 times 10 to the 8. So 2 is a part of the formula. We keep that. Pi is going to be 3.14, like we have in the question. And the radius, which is r, is going to be 1.5 times 10 to the 8. Now we multiply. We multiply 2 times 3.4, and 2 times 3.4 is 6.8, and we keep 1.5 times 10 to the 8. Next, we multiply 6.28 times 1.5, and we get 9.42, and we bring down a 10 to the power of 8. So that means that the distance that the Earth travels in 1 year is 9.42 times 10 to the 8 kilometers. Okay, let's move on to the next question. It says, so we know the distance that the Earth travels in 1 year. Now, what they want us to find out is the distance the Earth travels in 1 day. Now, 1 year is equal to 365 days. We already know that the distance the Earth travels in a whole year is 9.42 times 10 to the 8, but we need to figure out what's the distance that it travels in 1 day. So that means we have to divide. We have to divide the distance we got in the previous answer by 365 to figure out the distance in 1 day. So this is the distance for the whole year, and we have 365 days in a year, so we divide them. We're going to take 9.42 and divide it by 365. When we divide 9.42 by 365, we get 0.025808219 times 10 to the 8. We want to express it in scientific notation, so I'm going to move the decimal point twice to the right hand side. And so that means that we're going to have 2.5808219 times 10 to the negative 2. That's because I moved over twice to the right. And since I move over twice to the right, that means it's going to be negative 2. If I move twice to the left, it's going to be positive 2. Okay? Now we know if we have the same base, right? We add the powers. So it's going to be negative 2 plus 8, which is the same thing as 8 minus 2. So negative 2 plus 8, right, is the same thing as 8 minus 2, which is 6. And so our answer is 2.5808219 times 10 to the power of 6. Okay, that's going to be the distance, kilometers. That's the distance that you travel in 1 day. Okay, let's move on to the next question. It says, the diagram shows a cylindrical storage container of radius 1.5 and height 4.2. Using pi as 22/7, calculate the volume of the container when full. Now, if we want the volume of the container, what we need to do is we have to figure out what the formula is. And here we have a cylinder. So the volume of a cylinder is going to be the area of the cross section multiplied by the length or the height. Now the area of the cross section, this cross section is a circle, right? So we are dealing with the area of a circle. What's the formula for the area of a circle? That's going to be pi r squared. So pi r squared is the formula for the area of the circle. Now what is pi? Pi in this case is 22/7. And what is the radius? The radius is given explicitly to us, and it is 1.5. Now we have to multiply 1.5 times 1.5, which is 1.5 squared. And that gives us 22.25. So 1.5 squared is 2.25. And we put it over 1. And we have the 22/7. So we have to multiply 22 by 2.25. And we're going to multiply 7 by 1. And that gives us 49.5 all over 7 meters squared. And that's going to be the area of the cross section. Now I could simplify it some more, but I'm going to leave it right there because I need to use this number or this fraction to help me figure out the volume. Because remember, the volume is going to be the area of the cross section multiplied by the height. What's the area of the cross section? We got it right there, 49.5 all over 7. So we're going to take that area of the cross section and multiply it by the height. And so we have 49.5 divided by 7 multiplied by 4.2. And so we're going to multiply 49.5 times 4.2. And that gives us 207.9 divided by 7. And we get 29.7 meters cubed. And that's going to be the volume of this container. Okay, let's move on to the next question. It says the contents of the container are packaged in boxes with a square base of side 15 centimeters and 20 centimeters. Calculate the volume of a box, giving your answers in cubic meters. Now it's very important to understand that they want our answer in cubic meters, but here we are given the question in centimeters. So we need to convert these centimeters into meters. How do we do that? Well, so we have to take 15 centimeters and convert it into meters. And so how do we do that? Well, we said 15 divided by 100, and that's going to give us 0.15. And so 15 centimeters is going to be equal to 0.15 meters. And then we do the same thing with 20 centimeters. We divide it by 100, and that's going to give us 0.2. And so that means that we are going to be working with 0.5 meters and 0.2 meters. Okay, so now we need to find the volume. The volume is going to be the area of the cross section multiplied by the height or the length, which is 0.2 meters. Now, what's the area of the cross section? Well, the area of the cross section is going to be, they say that it's a square base, right? It's a square base. So if it's a square base, that means that the cross section is a square, all right? So that means we need to find the area of that. And the area of a square is just going to be length times width. And the length is 15 centimeters, sorry, 0.5 meters, and the width is 0.5 meters. Because it's a square, and so all the sides are going to be equal. So we have 0.5 meters times 0.5 meters, and we multiply that by 0.2 meters, and our answer is going to be 0.0225 meters squared multiplied by 0.2. And so our answer is 0.0045 meters cubed or cubic meters. And that's going to be the volume of the box. Okay, let's move on to the next question. It says, calculate the number of boxes that can be packaged from a full container. Well, here we're going to divide. So the number of boxes that can be packaged from a full container is going to be 29.7 meters cubed divided by 0.005 divided by 0.0045 meters cubed. Now, why would we do that? Well, remember this volume was the volume of the cylinder, 29.7 meters cubed. This volume right here, the 0.0045, is going to be the boxes, right? That's going to be the volume of those boxes. Now, if we want to figure out how many of those boxes can fit into this cylinder, we have to divide 29.7 by 0.0045. And then when we divide that, we get 6,600 boxes. So 6,600 boxes can fit into that cylinder that we saw earlier. Okay, so let's move on. Okay. Okay. Number of boxes that can be packaged, and this is the cylinder that we talk about. It's a cylinder. It's a cylindrical storage container. Okay, so let's move on. The next question says, 2013, the blades of a wind turbine are of length 32 meters. So this is the length right there, 32 meters. The point A on the tip of a blade traces out a circle as the blade rotates. So the blade is going to rotate, and it's going to trace a whole circle. Using pi as 3.14, calculate the distance traveled by the point A in one revolution. So what they basically want us to figure out is what is the distance, right? What is the distance? What is the distance around the circle? Now there's a name that we use for the distance around the circle. We call that the circumference. The circumference. So distance around the circle is going to be the circumference. Okay. The distance around, let's make this the distance around the circle. Okay, it's supposed to be like this. All right, that's going to be the circumference, right? So what we need to do is we need to figure, okay, what is going to be the circumference of the circle? Well, the formula for the circumference of the circle is going to be 2 pi r, where pi is 3.14 and the radius is 32. So we have to multiply 2 times 3.14 and multiply it by 32. And our answer is going to be 6.8 times 32, which is 200.96 centimeters. 200.96 meters. Now, what does that mean? Well, that means that the distance at this point is going to travel in one revolution. So the distance is this whole distance right there. This distance right there, the distance at this point is going to travel, all of this distance equals to 200.96 meters. And that's the distance for one revolution. All right. Okay, let's move on to the next question. It says they want us to figure out, they said that the rotating blades or the blades are rotating at 12 revolutions per minute. So these blades are rotating at 12 revolutions per minute. So in each minute, they're going to be able to do 12 revolutions. So it says calculate the speed at point A in meters per second. So they give us the speed of they give us the speed of the blades, which is 12 revolutions per 1 minute. Now they give us this. Now what they want us to find is also the speed, but in meters per second. So that's the difference. We were given it in revolutions per minute. Now we have to change it to meters per second. Okay. So let's do this step by step. So the first thing we need to remember is that the blades are moving at 12 revolutions per minute. That means every 1 minute, every time you have 60 seconds, every time 1 minute happens, that means you're gonna have 12 revolutions, right? 12 revolutions. So what does that mean? So how many revolutions are there in 1 minute? If there are 12 revolutions per minute, how many revolutions are there in, because we want it in seconds. So how many revolutions there are in, well, we know that there are 12 revolutions per minute. So how many revolutions are there in 60 seconds? Well, it's the same thing because 1 minute is 60 seconds. So that means that there are 12 revolutions every 60 seconds. So let's break that down again. There are 12 revolutions every minute. And we know that 1 minute is equal to what? 60 seconds. So what does that mean? That means that there are 12 revolutions every 60 seconds, all right? So what else can we deduce from that? If there are 12 revolutions every 60 seconds, the question is, how many revolutions are going to be in 1 second? Okay, so how many revolutions are there going to be in 1 second? So we have 12 revolutions per 60 seconds. How many revolutions are there going to be in 1 second? All right, that's a good thing to do. But before we do that, let's because it says meters per second, right? We already get the seconds, but we want meters, right? So how many meters is covered, right, in 12 revolutions? How many meters are covered in 12 revolutions? Well, we know that in one revolution, we saw this from the beginning. In one revolution, we know that the distance covered is 200.96 in one revolution, right? So if one revolution covers a distance of 296 meters, right? Meters, then that means that 12 revolutions is gonna cover 12 times 296, right? So that means that 12 revolutions is going to carry, what is 12 times 296? It's going to carry 2,411.54 meters. Okay, because 12 revolutions, because one revolution carries 200.96 meters. And so that means that 12 revolutions is going to be 12 times 200.96. And so that means that 12 revolutions is actually 2,411.52 meters. And so that means that we know that these blades covers a distance of 2,411.52 meters every 60 seconds, right? Or every 1 minute. What if I want to figure out what's the distance of it in 1 second? Like how many meters does it cover in 1 second? I'll be able to divide 2,411.52 divided by 60 to figure out how many meters it carries in 1 second. And when we divide that, we get 40.192 meters per second. And that's going to be the answer for this one. So the speed of the point A in meters per second is 40.192 meters per second. Okay, that's going to be the speed of point A. Okay, let's move on to the next question. It says that a holding tank A has a length of 20 feet, a width of 15 feet, and a height of 9 feet. Another holding tank B has a square base and a height of 12 feet. Both tanks hold the same quantity of liquid when full. This is very important. It says both tanks hold the same quantity of liquid when full. That means that that the volume of A and the volume of B, they are actually the same, right? Even though they look different, but that means that both volumes are the same. Okay, so they want us to calculate the volume of holding tank A. So this is holding tank A, right? And how do we find the volume of uh of this container? What we need to do, volume is going to be equal to length times width times height. So it's going to be 15, 20, and 9. And when we multiply that, we get 2,700 feet to the third power. All right, so that's going to be the volume of the holding tank when full. But what does that mean? If we know that the volume of this holding tank, which is this one, if we know that this volume is $2,700, if you know that that was your volume, so that is the volume of this shape. That means that this shape also has that same volume, right? Because the volume for these two shapes are equal. All right, so that means that the volume of A is 2,700 feet cubed, and that means that the volume of B is 2,700 cubed. Okay, let's move on to the next question. It says, calculate the base length of the holding tank. So you want to figure out the base length of the holding tank, so we need to figure out like what is this X, all right? All right, what are we gonna do? We're gonna say, okay, well, to figure out the volume of this shape, we need to figure out length times width times height. And so what is the length? And so we have X, right? X times X times 12 is going to be equal to 2,700. Why do we do that? Well, we know that ultimately whatever is the volume of B is going to be equal to the volume of A. We already know that the volume of A is 2,700. And so what we need to do is we need to figure the formula for B, which is X, which is the length, times X, which is the width, times 12, which is the height. And so that's going to be equal to 2,700. Right along. Let's multiply. X times X is going to be X squared, multiplied by 12. And then so we're going to be, so that means that we're going to have 12X cubed. So that means that we're going to have 12X squared is equal to 2,700. We divide both sides by 12. Right, so we divide both sides by 12. Okay. Now when we divide both sides by 12, what do we get? Well, those two are going to cancel out. All right. And so we are just left with X squared is equal to 27,000. Okay, so now we need to cancel. So we're going to do the square root of both sides. So we can take the square root of both sides. But before we do that, what I did here was I divided. So I did 27,000 divided by 12, which gives me 225. Then we can take the square root of both sides. All right, so be careful there. X squared is going to be equal to 27,000. Sorry, not 27,000, 2,700 divided by 12. And so now x squared is going to be equal to 225. Now we could cancel. So cancel the top with the bottom. We get that x is going to be equal to the square root of 225, which is going to be 15. So x equals to 15. Okay, let's move on to the next question. It says a cylindrical shape gasoline tank of a truck has 21 inches and 36 inches. Sorry, a cylindrical gasoline tank of a truck has a 21-inch diameter and a 36-inch and is 36 inches long. Using pi as 3.14, calculate the volume of the tank. All right, so here the volume is going to be equal to, indeed, the volume is going to be equal to the area of the cross section multiplied by the length or the height. Now, what is the area of the cross section? Well, the area of the cross section is going to be pi r squared because 2 pi r, sorry, I'm sorry, the area of the cross section is going to be pi r squared, and that's because we're trying to find the area of the circle, right? The area of the cross section. Okay, so let's multiply. We know that pi is 3.14. What's going to be the radius? Well, the radius is going to be 21 divided by 2. And what is 21 divided by 2? Well, 21 divided by 2 is 10.5. 10.5. So that means that we have 3.14 times 10.5 squared, right? What is 10.5 squared? That's going to be equal to 110.25 times 3.14. And then we multiply. We're going to say 346.185 inches squared. And so that's going to be the volume of the tank, 346,185. Okay, let's move on to the next question. Now that we get so first of all, this is the area of the cross section. I hope I didn't say that's the volume. This is the area of the cross section. The area of the cross section is going to be 346.15 inches squared. That's the area. But now in order to find the volume, we need to take that area of the cross section and multiply it by length. So I hope that's how I explained it. First we find the area of the cross section. That's what we did, right? Pi r squared. So pi is 3.14, r is 10.5. We square that, multiply, we get 346.185. This is the area of the cross section, not the volume yet. Now, in order to find the volume, what we need to do is we need to multiply the area of the cross section, what we just figured out, and multiply it by the length. And so that's going to be 346.185 times 36. When we multiply it, we get 12,462.66 inches cubed. And so that's how we get the volume of the tank, multiplying with the area of the cross section by the length. Okay, let's move on to the next question. It says a tank is filled with gasoline at a cost of $5.34 per gallon. We know that 1 gallon is equal to 231 cubic inches. So they're asking us to calculate to the nearest cent the cost of a full tank of gas. All right, so in order to do this, what we need to do is we need to take 12,462.66, and we need to, because this is inches cubed, and we need to change it into gallons. How do we do that? We divide by 231, and that's going to give us 53.950900909 gallons. So we took 12,462.66 inches cubed, and we converted it into gallons by dividing by 243. All right, so now we want to, so now when we know how many gallons we have, we want to figure out the cost of the full, now that we know how many gallons we have, we need to figure out the cost of the full tank of gasoline. And so that's going to be 53.95090909 times 536. And that's going to be 289.18768,727. That's going to be the cost of a full tank of gas. But they want us to figure the cost to the nearest cent. So that means that we have to that means that we have to consider, we have to basically round to the two decimal places. So this is going to be, we're going to underline 6. 6 is greater than 5, so that means we have to add 1. So we have 7 plus 1, which is going to be what? 7 plus 1 is definitely 8. And so that's how we get 289.18. Okay, let's move on to the next question. Here they ask us to consider the diagram. The diagram below represents a rectangular tank of length 22 inches and width 15 inches. And they tell us that the height is definitely going to be h. Okay. So now that we know that the height is h, they ask us to write down and simplify an expression in terms of h for the volume of the tank. So how are we going to get the volume of the tank? Well, we have to remember that this is a rectangular tank. And so that means that the volume formula is going to be length times width times height. And so it's going to be 22 inches times 15 inches times the height, which is h. So length times width times height. All right, so what is 22 times 15? 22 times 15 is definitely 330 h. And so we're going to multiply. And so we multiply in 330 times 8, but h. But we do not know what h is as yet. So since we don't know what h is as yet, we have to figure out what h is. And so let's go move on to B. B says that the tank holds 20 gallons of the liquid when full. Calculate the value of H. And understand that 1 gallon US is 231 cubic inches. So what we need to do is we need to change this, we need to change 20 gallons, right, into cubic inches. And we do that by definitely have to multiply, because 20 gallons, 1 gallon is 231 cubic meters. Sorry, 1 gallon is 231 cubic inches. And so if you want to figure out the cost of 20 gallons, just multiply that by 20. And 20 multiplied by 231 is 462, is 4,620. So that means that 20 gallons is 4,620 cubic inches. Now that we know the volume, right? So the volume of the tank is 4,620. That's the volume. We're going to take that volume and we're going to equate it to the expression of the total volume, which is 330 times h, which equals to 4,620. We equate those two values because both of them are showing us, or both of them are representing the volume of this rectangular tank. So what we need to do, we need to solve for h. So what we have to do, we have to divide both sides by 330. And then we're going to cancel this 330 and cancel that 330. So we're left with h is going to be equal to 4,620 divided by 3,030. Next, we're going to divide 4,620 divided by 330. And our answer is going to be 14. So that means that the height is going to be 14. Okay, let's move on to this next question. It says the diagram shows the top view of a rectangular case of cans. Each can has a diameter of 7 centimeters. Here they want us to figure out the length and width of the case. Let's first deal with the length. The length is going to be 7 centimeters multiplied by 6, which is going to be 42 centimeters. Why? Because if we look carefully, this is 1 can, 2, 3, 4, 5, 6. So if we go all the way across, that's going to be 6 cans. And so that means that the length is going to be 7 times 6. Now, if we want the width is going to be 7 times 4. Why 4? Because this is 1, 2, 3, 4. So the width is going to be 4. The width is going to be 7 centimeters multiplied by 4 because it's 4 cans, and we know that the diameter is 7 centimeters. So it's going to be 7 centimeters multiplied by 4, which gives us 28 centimeters. So the width is 42 centimeters and, sorry, the length is 42 centimeters and the width is 28 centimeters. Indeed, the length is the longer side. So the longer side is what we call the length. Okay, so let's move on to the next question. The next question says, calculate the area of the base of the case. So the area of the base of the case, well, the base of the case is just this rectangular portion right there. So this right there, this rectangle that we have here, right? This rectangle, that's the base of the case, right? So the area, the total area of this rectangle is what we call the base of the case, right? So we need to figure out that that area. So what we need to do is we need to multiply the length. So we need to multiply the length times the width. And the length is 42 centimeters. We learned that earlier, and width is 28 centimeters. And so that means that the area of the base of the case is going to be 1,176 centimeters. That's going to be the area of the base of the case. Let's move on to the next question. It says that the total area occupied by the cans is what we need to figure out. So how much area is occupied by all the cans together, right? So what we need to figure out is the area of one can. So if we could figure out the area of one can, and then all we need to do is multiply that by how many cans that we have, right? The total number of cans, and then we can get the total area occupied by the cans. So it's a strategy. The strategy is the following. We need to figure out, okay, we need to figure out what is going to be the area of one can, right? Once we figure out the area of one can, then we're going to multiply that area by the total number of cans that we have inside this box. Then we're going to multiply by the amount of cans that we have inside the box. And that's going to give us the total area occupied by the cans. Okay, so what's the area of, this circular portion, right? The top view. So that's a circle. So the area of one can is going to be pi r squared, because we're talking about that circular portion of the can, that area. And so pi is 22/7, right? That's pi. And the radius is 7 centimeters divided by 2. Now, why is the radius 7 centimeters divided by 2? Because remember, radius is always half of the diameter. And we just learned that the diameter is 7 centimeters, right? That's what they told us in the question. So the area of one can is going to be pi, which is 22/7, multiplied by 3.5 squared, right? Because that's the radius squared. Then we're going to multiply 3.5 times 3.5, which is 3.5 squared, and that is 12.25. We put it over 1, and we have 22/7. The reason why we put it over 1 is because we want to multiply these fractions. So we multiply 22 by 12.25. We multiply 7 by 1, and so we have 269.5 all over 7. That's the area of one can. Now let's divide it. So 269.5 divided by 7 is going to be what? That's going to be equal to 38.5 centimeters squared. Okay, let's move on to the next question. Not the next question yet, the next part of the question. Now we need to figure out the total area occupied by the cans. So how many cans do we have? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 cans. So we need to multiply this area that we got, 38.5 centimeters squared, and multiply by 24. And we get the total area occupied by the cans, which is definitely 424 centimeters squared. Sorry, not 400, 924 centimeters squared. Okay, let's move on to the next part of the question. It says, how many cans of soda did he buy? Well, it says Jim bought 5 regular cases of canned soda. How many cans of soda did he buy? Well, there in each case, right? In each case, you have 24, right? So in case number 1, you have 24. In case number 2, you have 24. In case number 3, you have 24. In case number 4, you have 24. And in case number 5, you have 24. So how many cans did he buy in total? It's going to be 24 multiplied by 5, which is going to be 120 cans. That's how many cans he bought altogether. Let's move on to this next question. It says AC is the diameter of a semicircle shown.